Okay, guys, this is just going to be a little background on functions. In class today, a lot of you seemed a little bit confused, so I just wanted to, I guess, back it up a little bit and refresh kind of what you should know from Algebra 1 with functions. A function is a relationship between two variables where one variable depends. Actually, let me write that. That's at the input of one variable, where the of one variable determines the other value, determines the value of the second variable. So if you go back to your Algebra 1, an example of a function would be something like y equals 3x. Say plus 1. This is an example of a function. Why is this a function? Because whatever I put in here for x will determine what y is. If I said, excuse me, if I said x equals 3, then you could figure out y by plugging it in. You would say y equals 3 times 3 plus 1. This would be 9 plus 1, and you would end up getting y is 10. So y depends on x. Whatever I get for y depends on what I plug in for x. So this would be the point where x is 3 and y is 10. Let's say I said x is 0. If I said x is 0, I would plug that in. 3 times 0 plus 1. And I would get 0 plus 1, y equals 1. So again, the point would be x goes first always, is always alphabetical. So it would be 0, 1. This is a function. Now, with functions, there are different ways to write functions. So this is y equals. You can also write a function in f of x form because f of x is the same as y. They are the same exact thing. If you see f of x, you can just replace it with y. If you see y, you can replace it with f of x. Now, sorry, 6 steps slow. Now for this, what you want to do, it will be the same exact thing, 3x plus 1. Now, f of x means function of x. Y is a function of x. What that means is that y depends on x. So f of x means function of x. That's how you would say it out loud. But again, when we read it, it's just f of x. So if you saw this or this, they mean the same thing. The only difference is that when it's in function notation, it won't say, like, if x equals 3, what's y? It'll just say f of 3. If you see f of 3, that means you want to plug in x, which is, in this case, this means x is 3. You want to plug in 3 to the function. So this means the same thing, but based on the notation, it'll be expressed differently. F of 3 means you plug 3 into the equation. And then you would get 9 plus 1. F of 3 is 1. I'm sorry, 10. And again, the same thing for a point. X is 3, y is 10. So that would be the point. Let's say I said f of negative 5. Then negative 5 gets plugged into the function. It's 3 times negative 5 plus 1. So this would be negative 15. Sorry, that was a negative 5. So this would be negative 15 plus 1. The answer would be negative 14. So again, x is negative 5, y is negative 14. So this would be kind of like an example of how you would have done a regular function. For these regular functions, they can also be expressed in graph form. Just going to make it a little smaller so I can show you what the graph will look like. If I was trying to graph this function, at this point, this is a linear function. It's going to be a line. And we just reviewed graphing lines. You should be able to do this one pretty easily. So if this was the function, you would have started from, again, if it's this way or this way, same thing. We would start from 1. Excuse me, put a couple dashes. I don't know why I didn't just put a graph in here, but there we go. All right, so we start from 1, and then we would go up 3 over 1, up 3 over 1, down 3 over 1, etc. This will be the graph of the function. So with these functions, you would get a graph. And let's just look at it and see. I tried to go over a few with at least with the first section today, with reading the graph. Excuse me. That didn't really go too great. So we'll do some more of that tomorrow. But when this is a point here on the line, and this is the point 0, 1. So again, that was one of the values. When you put in 3, you got 9. So what did you get? Oh, you got 10. So if you went to 3, it should be 1, 2, 3, 4, 5, 6, 7, or whatever. It should be about 10 if you count it up. But again, this is my hand done graph, so it's not all that exact. All right. So today we briefly talked about a piecewise function. So I'm just gonna give you again just a brief overview of what the difference is. So this is a regular function. The piecewise function, what we tried to talk about a bit today, is different. All right. So what a piecewise function is a function with multiple. So that multiple could be 2, it could be 3, it can be 4. A function with, I'm sorry, we could say where there are, but with multiple equations to determine as if I had the letters of the word here, the value of f of x. F of x is again y. Nothing crazy there. So what's going to be different about a piecewise function? Or what's going to make this harder from Algebra 1? This function up here is an example of a normal function. A piecewise function has multiple equations to determine the value of f of x. An example of a piecewise function would be y equals. Just going to look at 2 today. We'll do 3 tomorrow. Next session. It'll be something like this. Y, I'm sorry, you don't want y again. It'll be something like x plus 2. And then there'll be a restriction over here. And let's say this is when x is greater than 4. Then there'll be another one. And it'll be, let's say, 2x minus 3. And this will be when x is less than or equal to 4. Now, this is a piecewise function. There's 2 separate equations that determine y. Now, the first one says x plus 2, and the other one says 2x minus 3. But you're only going to use them with the indicated parameters or the indicated values. I'm going to put an A here, and I'm going to put a B here. So if I said if x equals 7, what is y? If x equals 3, what is y? If x equals -4, what is y? And if x equals 4, what is y? Now we're going to figure this out from this function and see what's different from the other stuff. So for this function, if x is 7, the piecewise function, the directives say, if x is greater than 4, we use this one. If it's less than 4, we use this one. So 7 is greater than 4. So that means I should be using A. So I'm going to use this equation. So I'm going to say y equals 7 plus 2. So in this case, we're going to get 9. Again, since it's greater than 4, I use the top equation. The second one says if x is equal to 3, what is y? So 3, where does 3 fall? Is 3 greater than 4? Or is 3 less than or equal to 4? 3 is less than or equal to 4. So I'm going to use the bottom equation. So I'm going to use y equals, and again, I'm going to use this one now. 2 times 3 minus 3. I'm plugging in the specific x value. So this is going to be 6 minus 3. So for this one, I get y is 3. Let me put a b there. So we use b for that one. For the third one here, it says if y is equal to -4. First of all, decide, do we use A or do we use B? -4 is less than 4, so we're going to use B again. So again, I plug into the bottom equation. It's going to be y equals 2 times -4 minus 3. So that's -8 minus 3. I get -11. And then the last one says if x is equal to 4. So equal to, again, I look at the restrictions. This one says greater than 4. This one says less than or equal to 4. So that means I'm using the bottom one again. So I'm going to do y is equal to, again, I'm plugging in the given value. I'm going to do 2 times 4 minus 3. So that's 8 minus 3. For this one, I get 5. So this is an example of a piecewise function. And that is how you would evaluate it, like for some given values. Now, note that if it was written this way, f of x equals x plus 2 it's the same thing, but it would have been written differently underneath. It would have looked like this. F of 7, f of 3, f of -4, and f of 4. That means you plug in 7 for x. So same things as, these other ones here. It's just a different notation. This is like slope-intercept form, basically, or solving for y, etc. The other one is called function notation. Anyway, I'm going to also just look at a quick graph of this. This will be the only one we're going to do, and then I'll post this video. A quick graph of this, the way this would look. We'll go through the graphs on, in class on Wednesday. Actually, let me insert a graph because my graphs look kind of crazy. All right, so here's our graph, guys. A little bigger. All right, so for this graph, when it's time to graph. Now, for the previous example, again, when I showed you the graph, we just started at 1, up 3 over 1, etc. We cannot do that with a piecewise function because if we started here at 2 and then just went, up 1 over 1, etc. with the slope, that's one function all the way. That's not what we have here. We have two separate functions coming together for one thing. So it's not just going to be one set line. So you have to take that into consideration. I'm going to have to look at what values work for one and which values work for the other. So I tend to tell my students to set up a quick table. You don't have to, but you can do it however you're comfortable. And you only need about two, at least two values, but you can do 3, but you don't need more than that in each section. So for A, I'm going to start with A. The equation I'll put in the middle, x plus 2. Then I have my x value and my y value. So I always want to start with whatever value is indicated with the less than, greater than, etc. So I want to start off with 4. And then I'm going to plug that in. So it'll be 4 plus 2. And that'll be 6. So this first point that I would be able to graph would be 4 for x, 6 for y. And then my next point, this says for A, x is greater than 4. So the next value I want to plug in would be something like 5. And I'm going to plug that in. So 5 plus 2, we get 7. So this will be 5 comma 7. All right. And that's enough. Again, if you want to put another point for 6, you can. You can put 6 plus 2. That's 8. The point is 68. But again, you don't have to. I'll be fine with the 2 points. For B, now we look at the second function. For the second function, it's 2x minus 3. I'm going to write that in the middle. And x and y. Now for this one, it says x is less than or equal to 4. Again, I always want to include this cutoff value. So I'm going to put 4. And then if it's less than or equal to 4, we're talking about things like 3, 2, 0, -1, etc. Obviously, again, I already said you only need like 2 values, so we'll just do like a couple. Again, you only need 2, but I'll put 3. So I plug in 4. It'll be 2. It'll be 2 times 4 minus 3. 2 times 4 is 8. 8 minus 3 is 5. Put in 3. 2 times 3 minus 3. 6 minus 3 is 3. 2 times 2 minus 3 is 1. Okay. So now we can graph it. Before we graph, though, we have one thing to consider. 4 is common in both of these sets. One of them is going to be an open circle and one is going to be closed. This one is going to be open because it's not underlined. And this one's going to be closed. You can write open there if you want, closed. You can just draw the dot, but you need to keep that in mind because it's a shared value in both, and it'll only go with one of them. It'll either be in the, the greater than category or the less than, etc. It will not belong to both. So now let's graph this. The first point is 4, 6. 4, 4 and 6. This is open. Then I have 5, 7. And then I have 6, 8. So that will look like this, going that way. The other one will be 4, 5. 4, 5. That's going to be closed. And then it'll be 3, 3. And 2, 1. And it will go this way. These piecewise functions will be strange looking. They won't be connected. There'll be like two, 3 different things going on. An idea of it is it can look like this. Then you got something like this. And then you got something like this. Who knows? But it will not look uniform. It'll be like separate pieces of the graph. Again, we'll spend more time graphing tomorrow. I'll give you guys just a few plugging in for tonight's homework. Have a good day. Remember, quiz will be your next session.